Hey everyone, welcome back to another Godot 4 tutorial. Today I'm going to be showing you how to create an in-game pixel art painting system that can display your paintings as an in-game texture on a 2D sprite. This will work with a colour picker, and data can be saved using Godot resources, so it can be easily bundled with the inbuilt resource saver if you need. Starting with a more or less empty project, we'll save down our default scene just as a game and then create a new scene for a painting that will act as the in-game asset that will display your final masterpiece. All this scene needs to include is an empty sprite for the actual painting and optionally another sprite for a frame to showcase it. Once we've created those nodes, I'm going to attach a script. For now, we're just going to reference our painting sprite, which will override from a function which we'll call apply texture from resource. We'll actually write the code for this a little bit later in the video. Now that we have our painting scene, I'm just going to drop it into our main scene and add a camera 2D as a child just so we're focused in on the node. After that, it's time to configure our user interface. I won't walk you through all the exact steps I go through here, and ultimately you can configure your UI however you prefer. For me, I'm just nesting a series of containers and various layouts and margins. The main nodes I want to call out that aren't layout focused elements are the grid container, which will be populating with lots of tiny little cells that will comprise our actual canvas, and this very cool color picker node, which I didn't actually know existed until I made this video, which even includes eyedropper functionality that can select any color from your in-game window, which is really cool. I'm also just adding a couple of buttons at the bottom, which will essentially act as an undo and a save and close to push your painting into the game. Now let's add a new canvas layer node into our scene so that we can nest our canvas under it as a child and it will appear above all other elements in the game. We'll be wanting to hide our user interface by default, and we'll write a quick game manager script to open it on a particular action. Obviously you can set any number of things in your game to show the interface to start your drawing, but for this tutorial I'm just going to add a paint action into the input mapper and map this to spacebar. While I'm in the project settings, I'm also going to add this game manager script as an auto load so that it runs as a singleton, which basically just means a persistent script of which there'll always be exactly one version running in memory that can be accessed by or access any other node in the tree. Once we've done that, I'm going to create a couple of resources for managing our data. If you're not familiar with the resource system in Godot, I would suggest reading the documentation, or there are plenty of really good tutorials out there explaining the concept really well behind resources and what their benefits are. One of the major plus sides is it makes saving down data to disk really easy to implement using the built-in resource saver. The only data we'll actually be storing in this resource is a flat array of colours which will represent each little cell in our grid. We'll then just create a couple of functions that can take in our grid as a parameter and either load our colours into that grid or save our colours down from the grid after we finish a painting. Once we've got that created, I'm also just going to create a quick save data file to store it in. This isn't really necessary for this tutorial as it's the only data that we're working with, but this kind of file might be where you store all kinds of data in your game depending on your needs, and by nesting it inside a single save data resource, it allows you to save and load it really easily just through that single resource via the resource saver. I can link a really good tutorial by GD Quest which will delve into this in a bit more detail. Now that's all the foundational nodes and classes created, the easy stuff. The next bit is where the most complexity comes in, and that's creating a workable canvas that the player can interact with mouse clicks. I'll do my best to break down the code as we're writing it here, but you don't need to stress too much because I've also included in the description a link to a sample project on GitHub which contains all the code and files that we've created in this tutorial. First thing we've done is define some variables at the top. One constant for the grid size, which is the length in either direction of the canvas. In our case, I'm making it 32 by 32 pixels. A default color to use, we'll just make it red, and a variable that will determine whether or not the user is actively painting on the canvas. We also need to grab references to our grid container and color picker to interact with through the script. When the node is ready, we need to generate our grid of 1024 cells and populate our grid container with them. We do this by looping through the full grid size and creating a new texture button, in this case, which just handles button clicks but can display any texture, setting a few defaults like the cell size, its texture and colour, and finally adding it as a child to the grid. The texture I'm using is literally just a white 1x1 pixel PNG that we can then modulate to whichever colour we need. Don't forget to decrease the gaps between each cell in the grid container like I did, or you end up with a very divided looking canvas. Next, we need to handle our mouse movement. We can't just rely on the built-in button functionality alone, as it won't allow the player to click on one cell and then still holding their click, move their mouse to another to draw continuously. We therefore activate our isPainting variable on the first click and deactivate it again once it's lifted back up. While isPainting is true, we then need to find which cell is under the mouse cursor while it's moving, and then modulate the colour to that active colour. I will just mention that while I'm recording the voiceover, I've realised that we probably don't even need to use the texture button node type anymore, as we're not relying on the button presses connection. We can probably just use a regular texture, which might slightly help the performance. I'm not going to re-record this whole tutorial though, so I'm just going to live with it in mind, but I suggest that you take a look at doing that instead. To calculate the cell under the mouse position, we just use the global position of each cell, and then the size of each cell to calculate when the cursor is within the bounds of that cell. And there we go. That wasn't actually too complicated in the end, and we're now able to draw on our grid by clicking and moving the cursor around. Exciting. We're very nearly there now, only a few things left to hook up. First is the colour picker, which is easy as hooking up the node signal for colour change to update our active colour. As I mentioned before, this node also allows an eyedropper to select colour already used on the canvas, or in fact anywhere else on the screen, which is really handy. Next, we need to hook up our buttons, starting with the on, save and close. First, let me just make sure our resources that we created earlier are all hooked up correctly, because there are a couple of things I forgot to do, like add a class name to save data and adding references to everything in the right places. And now it's time to go back and write our apply texture from resource function that we started earlier. This converts our flat one-dimensional array of colours from the grid into a two-dimensional matrix according to the grid size. It then creates a new image texture, using the setPixel method on each cell according to our stored colour to then be applied to our Sprite2D texture. Finally, for the reset button, we're just reloading the grid from the last time we saved the resource using this save and close button. And that's it. There's of course loads more you could do with this to expand on it, looking at kind of the ease of use tools that you might get in lots of other painting software, such as a fill paint bucket or colour palettes or shapes, etc. But this should hopefully give you the foundation to explore further on your own. I'd love to see anything you do manage to create using this method, so please do drop a comment or find me on my socials linked in the description. If you need any help as well on any of the things that we've done here, then please do just let me know and I'll try to help where I can. And of course the code is all down in the GitHub linked in the description as well, so feel free to check that out. Until then though, thank you so much for watching and I'll catch you in the next one.